These are the notes for section 2.1. It's our first section in chapter 2. It's going to be mostly review today. Hopefully most of this is familiar to you. So this section is about graphing. You'll want to be taking these notes on graph paper because you're going to be drawing several graphs as you guys do this. So I want you guys to go ahead and draw an XY axis. You do not need to put the numbers on the axis. This is just the one that I found, but you don't have to write 1, 2, 3, 4 or anything on either the X or Y axis. So the first thing I want you guys to label on your graph is that this horizontal axis is what we call the X-axis. And the vertical axis is called the Y-axis. This whole thing is called a coordinate plane. And we refer to this point 0, 0 as the origin. 0, 0. So let's talk about when we put a point on our axis. So for example, we're going to plot the point 3, negative 2. So I'm going to go over to 3 on my x-axis, negative 2 on my y-axis. So we call that a coordinate point, and it has two coordinates. The point is 3, negative 2. That's how we write it in parentheses. So its x-coordinate is 3. That's where we go on the x-axis. It's how far left or right we go. And its y-coordinate is negative 2. Whoops. Its y-coordinate is negative 2, so we go to negative 2 on the y-axis, so that's an up or down move. So since it's negative, we go down. I'm hoping that we remember plotting points from previous years here. So what I want you guys to do is to try plotting these points, negative 4, 3, negative 5, negative 3, 0, 4, 4, negative 5, and 2.50. I want you to make a new axis. Don't use the same set that you just made. Make a new XY axis, and I want you to try plotting those points. So hit pause, and then hit play again when you're ready to take some more notes. All right, so a graph has 4 quadrants. You might remember this. If you draw an X and Y axis here, they make a C. So it starts over here in the upper right corner. That's quadrant 1. And we always write them with Roman numerals. This was quadrant 2, quadrant 3, and quadrant 4. The reason these are named is just so that it's easy to communicate with people about what part of the graph we're talking about. So just make sure you know those, and you can remember that they go in a C like this, 1, 2, 3, 4, in a counterclockwise motion. What I want you guys to do next is I want you to draw a new graph, and I want you to try plotting these 1, 2, 3, 4 points, 1044, 14, 120, 20, 130, and 8, 150. Now I want you to be sure and select an appropriate scale for each of those axes. I should say axes. That's a plural of axis is axes. And I want to let you know that you can, like let's say your y values didn't start. Let's say your y values ranged from, oh, I don't know, 100 to 150. And so you kind of wanted to skip all those numbers between 0 and 100. You can draw a little zigzag and then start your axis. And that means there's a bunch of numbers in here I'm skipping. I'm going to go straight to 100, and then I'm going to go by maybe tens. Just make sure that whatever you decide to go by, you go by it the whole time on that axis. You can go by different scales on different axes, though. That's okay. You could go by 1s on the x-axis and 10s on the y-axis, and that would be okay. Just make sure that if you're going by 1s on an axis, you have to go by 1s the entire time. So go ahead and pause and try plotting those 4 points on a graph for me. I'm going to have someone show theirs to the class on the document camera tomorrow. Skipped ahead a little bit there. All right, so I want to do an example. You're going to get some problems that look like this. It's going to say determine whether a point or multiple points, this one is 3 points, 4, 2, negative 1, negative 4, and 2, 5. It says determine if those are solutions of the equation y equals 3x minus 1. So we're going to do just one of these together. We're going to try 4, 2 together, and then I want you guys to try the other two on your own. So we're going to try the point 4, 2. And we're plugging it into this equation, y equals 3x minus 1. When it asks if it's a solution, basically what it means is if we plug a 4 in for x, is y actually 2? Do those values work at the same time? So it's also asking, is this point on the line if we graphed this equation? So that's kind of asking two things here, because it all kind of means the same thing. So what we're going to do here is we're going to plug in the 4. Since it's our x coordinate, it goes x, y, just like the alphabet, x, y, z. That's how you can remember that x comes first. Since 4 is the x coordinate, we're going to plug that in for our x value. And 2 is our y coordinate, so we're going to plug that in for our y in our equation. So I'm just going to rewrite this equation with those numbers plugged in for x and y. So I'm going to write 2 equals 3x, and x is 4, it's multiplying since they're next to each other, minus 1. So let's see if this is true on each side of the equation. So I have 2 equals, well, 3 times 4 is 12, minus 1 is 11. Well, that's not true, so we can say no. That coordinate is not on that line if we graph y equals 3x minus 1, and that x and y do not work in that equation. So I want you guys to try the other 2 points on your own. See if -1, -4 is a solution of that same equation, and see if 2, 5 is a solution of that same equation. All right, we're going to talk about graphing lines. We did a lot of this at the beginning of 8th grade math. So when you have an equation of a line, it's written in the form y equals mx plus b. The m is our slope. Okay? That's one thing about the m. The m tells us our rise over run. It tells us how slanty a line is. It tells us how steep is the line. It measures the steepness of the line. The m is always x's coefficient. So it's always the number right next to x. That's always your slope. Now your slope can be one of 4 different things. Okay? Your slope might show the line going up as you go from left to right. It's a positive slope. It might be going down as you go left to right. That's a negative slope. It might be going straight across. That's a 0 slope. And it might be going straight up and down. We call that slope undefined. We'll go over why those things are true in class, and remind me, and we can watch the slope dude video if you guys remember that last year to remember it. So that's what the m, that's what the coefficient of x tells us, how slanty the line is, tells us if it's going up or down, horizontal or vertical as well. Then we've got the b. B is our y-intercept. So that's where the graph hits the y-axis. So if we draw a graph, that point where it hits the y-axis is our b. It could be positive or negative depending on where it hits the y-axis. So we're going to do an example here. We're going to try graphing y equals -1/2 x, and that's it. You can't see a y-intercept, but there is a y-intercept. You can try and think about what it might be. I'm putting a graph on here so I can graph this on here. Alright, so I'm actually going to go down here and write some steps to graphing lines. So the first thing you want to do when you graph a line is you want to plot the y-intercept first. Which makes sense because the y-intercept is your starting point. You need a point to go off of when you're graphing your line. So you plot the y-intercept first. Then you use your slope, which remember is rise over run, to plot more points. And the rule I have is that you need to plot at least 2 more points. You need your y-intercept at least 2 more points. I know that it only takes 2 points to make a line, But just to make your line neater, I want you to plot at least 2 more, and I want you to use a ruler, at least when you're in class graphing. I want you to use a ruler. Actually, you should have a ruler. It's on the list of supplies. So we should all have a ruler so we can graph nice, neat, straight lines. So for example, we're going to plot y equals negative 1/2 x. Let me rewrite that because I prefer to write my fractions this way. Negative 1/2 x. Now we're supposed to plot our y-intercept first. We can't see a y-intercept, so it really just says plus 0. That's our y-intercept, 0. It hits the graph at the origin. Now we're going to use our slope to plot some more points. So our slope is negative 1/2. Now remember, you can put that slope wherever you can put the negative sign wherever you want. But just think about the fact that this slope's negative, so our line's going to be going down somehow. So if we're looking at this slope as rise over run, we're going to be rising negative 1. That means go down 1 and run 2, go over 2 and put a point. Now you can continue doing that. Go down 1 over 2 and put a point. But what if you wanted to go in the opposite direction to extend my line not towards the right but towards the left? So what you can do, instead of going down 1, right 2, you can switch both directions. Go up 1, left 2, up 1, left 2, and then put a point. So you can go in either direction. Then you're going to draw a line through your points. I'm going to use my line tool here, but you should use a ruler, and you should make it nice, neat, straight, and it should extend from one edge of your graph to the other. So I want it to go all the way from edge to edge. It should not be short and stubby, and it should have an arrow in each end, because lines go on forever unless someone tells us otherwise. I want you guys to try graphing on your own, a new line. Whoops, didn't switch back to my marker. I want you guys to try graphing y equals 2x minus 1. So make a new coordinate grid there, make a new x and y axis, plot your y-intercept first, and then use your slope to plot more points. I'm hoping this is something you somewhat remember from last year, and if it's something you think you need more help on, let me know and I can get you some extra practice. Alright, now we're going to talk about graphing nonlinear equations. So these are different because they're not in the form y equals mx plus b. You can't just graph a slope and a y-intercept. So I want you to take a second and write down these 2 steps. Step 1 is to make an xy table. So I want you to make sure you choose at least 2 negative. Make sure you choose, just a second. Oh, I thought I was going to sneeze. Choose at least 2 negative values. Choose the value 0. And choose at least 2 positive values for x. Then what you need to do is plot all those points that came from your xy table and draw a line or curve. So go ahead and pause the video if you need more time to write those down. So for example, we're going to graph the equation y equals the absolute value of x. So our first step, like I said, is to make an xy chart or an xy table. I want to choose at least 2 negative values for x. I'm going to choose negative 2 and negative 1. You want to choose 0, and you want to choose the values, at least 2 positive values for x as well. So now what you're going to do is just plug those values of x into your equation and find out what y ends up equaling. So for example, if I plug negative 2 in my equation, I get y equals the absolute value of negative 2. Well, the absolute value of negative 2 is 2. So my y value there is 2. Now I'm taking negative 1 for my x value, so I'm doing the absolute value of negative 1. So y equals the absolute value of negative 1, and that's 1. Y is 1. Now I'm doing that y is the absolute value of 0, and remember that's 0 because absolute value means distance from 0. So it always turns positive because distance cannot be negative. And then last, we're going to take the absolute value of 1, which is 1, and then the absolute value of 2, which is 2. So now that we made our XY table, we just need to plot these points on our grid. So I'm going to start here with -2, 2. You can think of this like a coordinate point, -2, comma 2. I'm going to go over to -2 on my x-axis, up to 2 on my y-axis, and put my point. Now I'm going to do the point -1, 1. So I go over to -1 on my x-axis, up to 1 on my y-axis, and put a point. I meant for that to be green. They're showing up blue. Now we're going to plot the point 0, 0. Remember, that's the origin right there in the middle. And then we'll plot the point 1, 1, so over 1, up 1. It really doesn't want to make any dots green, does it today? And then we're going to plot the point 2, 2, so over 2, up 2. So we can kind of see what that graph looks like. It's not one straight line, it's kind of broken into 2 straight lines. So it extends this way and this way. So you want to do enough points to make sure you can really see the shape of your graph. I'm going to give you guys one of these to try. I want you to try graphing y equals x squared minus 5. So remember, you're going to make an xy chart. Choose at least 2 negative values for x. I would probably just start with -2 and -1. Choose 0, and also choose 1 and 2. I'll give you a hint. When you graph this, it should look like a letter in the alphabet. Kind of like the last one. The last one looked like a V. This one should also look like a letter in the alphabet. Alright, so when you finish graphing that, you are done, and you guys did ask for a joke, so I found a math joke for you. So here's the joke. Alright, so there's a farmer, and he farms sheep, and he has 33 sheep. And he sends his dog, let's call his dog Miko. It's a herding dog. So he sends his dog Miko out to herd up all of his sheep, and Miko comes back and says, Miko's a talking dog. Miko says, all right, I herded up all your sheep. And the farmer says, well, how many were there? I want to make sure I had all of them. And Miko says, there were 35 sheep. And the farmer says, what? I started with 33 sheep. How is that possible? And Miko says, well, I rounded them up. Get it? That was a good one, right? All right, I'll try to get some better jokes for next time. All right, come to class with any questions you guys have.